that makes sense. Okay, so let me quickly introduce myself. My name is Thorsten. I work as a consultant with ThinkTecture here in Germany. So what we typically do is we help developers adopting new technologies. I'm with ThinkTecture for, I think right now, seven to 8 years, something like that. And I mainly focus on cloud native. And if cloud native means public cloud to you, then it is obviously we just talk about Azure because that's what we know, that's what we do for years. And personally, I also focus on Kubernetes for the last 5 to 6 years or so, and containerization with Docker. And so I think that's pretty much the most interesting thing on that slide is obviously my mail address or the Twitter handle. If you have any questions, don't hesitate, just reach out and ask. And I regularly blog about those topics on my personal blog and on our company blog as well. Alrighty, so for today, as Matt already mentioned, is all about Azure Container Apps. So the latest and greatest service that we can get when it comes to running containers in Azure. And I mean, containers in Azure, that's all over the place. So obviously the first question is, do we really need another service to run containers in Azure? Because there are plenty of services already, being able to run our containerized workloads. And the quick answer to this is yes, we do. But the question is why, right? So why do we need another service to run containers? And if we take a look at the existing opportunities, so just, focusing those services that we can use to run, like, let's say the typical line of business applications where we have, for example, let's say Blazor frontend that must be served somehow using a plain old web server. We have some APIs and stuff like that running in the backend, and have some satellites that call into our service from time to time, perhaps it's cron jobs or so. Then we have plenty of options, right? And I think that the rock star when it comes to running containers in Azure is obviously AKS, so Azure Kubernetes Service. But the pricing is a little bit tough, let's say it that way. So it may quickly sum up on your monthly cloud spending or on your monthly bill that Microsoft sends you over every month when you use Kubernetes in a way that it is able to handle production workloads. So there is no serverless pricing, although we have Azure Container Instances for quite a while right now. But they are very limited when it comes to functionality, right? It's more like a dump container, or perhaps some semi-connected containers that you can run in Azure Container Instances. So there are certain, let's say, patterns in distributed applications where ACI, so Azure Container Instances, make sense. But when we want to orchestrate microservices architectures or distributed systems, then we typically want to use something like Kubernetes to get all those nice features that Kubernetes brings to the table. But it's really, really complex, right? So Kubernetes, I mean, deploying apps to Kubernetes is one piece, but managing, maintaining, hardening, securing a Kubernetes cluster, that's an entire different story. So what we see in at least in those countries we operate, so that's typically the German-speaking countries, and maybe over here and there some consulting stuff in the US, we see all the companies struggling with finding Kubernetes people. If they find Kubernetes people, it's really hard to hire them because they are quite expensive these days. And if you have them on board, it's really hard to keep them. What I see from German, especially from German or European customers, is that sometimes Kubernetes, that's a bad comparison, but let's do it. It's like SharePoint 10 years ago. It's a strategic development, right? We use Kubernetes to use Kubernetes. Doesn't matter if we need it or not. So sometimes Kubernetes is an overkill. And I think that's where Azure Container Apps has its sweet spot. So Azure Container Apps will address all of those, let's say, pain points that I've listed over here on that slide. And yeah, will give us another opportunity to run our containerized workloads. So we have obviously Azure Web Apps for containers, like the classical app service with a reverse proxy being deployed to the app service that's forwarding HTTP calls, appearing on the app service, let's say on port 443, to a specified port of your container that will be run behind the scenes by Azure App Service. So that's quite good for, let's say, projects where you are in the phase of, migrating from regular distributables over to containers to, at some point in time, perhaps adopt Kubernetes. So I see, personally, I just use it as a migration step in the middle. Then we have container instances, which is, for example, quite good service to do burst mode. For example, if you have to, let's say, create PDFs for thousands of customers on a certain point in time, you can just spin up 1,000 containers in Azure Container Instances and have those creating the PDFs. And once they're done, they get terminated, and you don't have any spendings. So that are quite good scenarios for Azure Container Instances. However, although it's serverless, although it's Azure and it scales up to infinity, there are some restrictions on how many containers you can spin up in an hour. So that's definitely something you should keep an eye on if you're thinking about moving some workloads over to Azure Container Instances. Then there's Azure Kubernetes Service, as I said, the Rockstar, great managed service that allows us to use latest and greatest Kubernetes with powerful integrations. I think currently in preview we got GitOps, and we can bring custom network plugins and stuff like that. But all those great features also bring a lot of complexity onto the table that you have to deal with somehow. And last but not least, there's Azure Container Apps, which is, right now in preview. So it's a nice addition to that, compute capabilities that Azure gives us to run our containers. There are obviously more special, or let's say there are other services for special workloads where you can bring in containers. So these are just the services, focusing on, let's say, general compute. So that's the new landscape from now that we can deal, or we can use as developers. So let's dive into Azure Container Apps. So it's a serverless platform. That means although it's based on Azure Kubernetes service, we don't have any access to that underlying Kubernetes cluster. We don't have to care about hardening the Kubernetes cluster. We don't have to pay for anything. So we are only charged by actual consumption. That means if we have several containers running in Azure Container Apps, we are charged obviously per CPU, per memory, multiplied by the seconds or minutes that the container is being executed in that period. So it's fairly similar to the pricing that Azure Container Instances have. So it's a real serverless consumption-based pricing model. The good thing is it's, although it's a fully managed, or it's a serverless service, it's not homegrown, let's say it that way. So Microsoft built Azure Container Apps for powerful open source projects. Obviously, Kubernetes, they were leveraging Azure Kubernetes service under the hoods. Then there is, let's take Envoy. So Envoy is a proxy that is deployed into Kubernetes and is able to not just route requests to certain containers in a Kubernetes cluster, it's also able to bring in functionalities like for example, traffic splitting or retry patterns and stuff like that. So the Envoy is really taking care about network stuff in Azure Container Apps. Then there's Dapper, so the distributed application runtime, yeah. That's an optional addition. So if you're using Dapper to build your microservices or distributed architecture, then you can just run it in Azure Container Apps. So it's 100% optional. That's important to recognize. And so it's no vendor login to Dapper if you use Azure Container Apps. And last but not least, there's KEDA, so Kubernetes event-driven applications that allows us to scale out, so to horizontally scale certain parts of our overall application on contextual load. For example, we can say, hey, there is a container that is responsible for, let's say, processing orders. And if the queue where orders will be persisted has more than 100 orders in the queue, then it should scale up to having 10 order services instead of just one, right? So we can scale dynamically depending on actual contextual load that is in our application instead of relying on, let's say physical metrics such as CPU utilization or memory allocation. So those are the 4 building blocks that the team took and compiled them or concatenated them into the service what we today call Azure Container Apps. The nice thing is that it tries to hide as much complexity as possible from us as consumers, which means we don't have to deal with Kubernetes CLI, we don't have to deal with Dapper CLI, we don't have to care about proxy configuration. All that stuff is hidden from us. So we can really, I mean, that's the promise that we got since 20 years ago, right? We can focus on building applications. But as you will see in a couple of minutes, they try to minimize the configuration aspect as much as possible. And that's why the team is what I recognize a little bit carefully about which capabilities they bring into Azure Container Apps, because they want to hit that sweet spot of having as less configuration as required to get something up and running in the cloud using container technologies. That brings us to, okay, what kind of applications can we run in Azure Container Apps? So right now, Microsoft advertises it like, okay, you can run microservices. That's true. You can take your, let's say, HTTP-based or gRPC-based applications that use, let's say, message queuing pattern to communicate with each other. You can take those and run them in Azure Container Apps. That's a no-brainer. Then event-driven applications, obviously, you can do that because of KEDA. And then there's background processing. So the typical, the cron job that runs at 5 a.m. in the morning, dealing or do some heavy data lifting or processing stuff in the database. That's technically, theoretically, it's possible. Microsoft has a guide how to do it. From my point of view, there are better opportunities to do it right now. But there are already work items in the GitHub repository asking them to bring in first citizen support for Kubernetes cron jobs, because Kubernetes has solved that problem of running cron jobs in parallel or with fancy configurations. But Microsoft has not yet adopted that let's say that object type and made it available to Azure Container Apps. Right now they use a KEDA-based approach that's a little bit awkward. Yeah, it's technically possible, but from my hands-on experience, I would stay away from the background apps for now. One thing that's important to know, in Azure Container Apps, you're only able to run Linux containers. There is no Windows story yet. And I have no information about if that yet turns into, we will get it at some point, or if it stays how it is. Architecture-wise, it's x64 based architecture Kubernetes. So there's no ARM support right now in Azure Kubernetes service on the basement. But the AKS team is working on that. So maybe we will see ARM support also in Azure Container Apps at some point in time. But right now it's Linux containers on x64 architecture. So for those of you that are familiar with Kubernetes or have worked with containers, perhaps, there are some familiar terms perhaps on that slide. So that's a drawing that I grabbed from the official documentation that little bit, introduces the building blocks that we use to take our containers and run them in Azure Container Apps. And let me quickly, so there's my mouse. So we have an environment that's a blue border around it. The environment you can think of, that's like a logical container where we can throw in multiple containers that can talk to each other. So for example, if your service consists of 2 backend APIs that must communicate with each other via gRPC, via HTTP, so kind of direct connection between each other, then that's a sign that those 2 applications should go to the same Azure Container App environment. Every container app, no, let's flip it around. So if you have a container image, right, you can take that container image and run it on your local machine. Then we say, okay, right now it's a container, right? The image gets instantiated and it becomes a container. A plain Docker container is not capable or not powerful enough to, from Kubernetes point of view, because Kubernetes, want to bring in health checks and stuff like that, and resource limits. So how many CPU can a certain container allocate and stuff like that, right? So that's why Kubernetes introduced the term pod. So a pod is at least one, but it can be multiple containers that run on a virtual host. So they share the same host name, the same IP address. And they are like a atomic unit. And Azure Container Apps also leverages that concept under the hood, but it's hidden from us, right? So we have a container, we throw the container over the border towards Azure, and we say, okay, I want just that container, right? So we immediately get a revision, and then we can, then the container gets executed. We can configure a container app to have multiple revisions, so we can pinpoint or we can route requests to certain revisions. Or we can, Azure Container App, ask to do some kind of traffic splitting, right? So for example, that 90% of the requests go to the stable version and 10% go to the preview version. If you think about, bringing in some early adopters that may have a sneak peek on what's coming up in your application. So it's a lot of Kubernetes specifica, but what Azure Container Apps really asks you to do is bring or create at least one environment in your Azure subscription, and then you can deploy your container apps into that environment. Alrighty, I hope that makes sense so far. If not, if you have any questions, just unmute yourself and ask. All right, so let's quickly, for those of you who haven't worked with Kubernetes that much, let's cycle once again over the building blocks. So Envoy is acting as a transparent network proxy where all requests go through. And it also acts as a so-called ingress controller. The ingress controller is like that piece of software, handling all incoming requests into a cluster or into an environment and routes requests depending on the request host name to containers. All of that obviously done using a virtual load balancer to ensure that you have running multiple instances of a certain container image, that those are, that not all requests are routed to a single container, which could be a little bit dangerous. In Azure Container Apps, we have just a Boolean, let's say it that way. It's just two options. We can enable or disable ingress. So we can say, okay, let's say this container should be reachable from the internet or not. And with the virtual network integration, we can say, okay, this container, so reachable from the outside means in that case reachable from the virtual network infrastructure. Or we can say this particular container is just accessible from within that Azure Container App. Right now we got traffic split. I quickly touched that one, that we can, say 90% go that direction, 10% go that direction. That's it's okay, but the use cases for simple traffic split are not that common so with the apps I have, right? So if you have, for example, a single page application running or talking to an API, it's pretty tough to send 90% to the old version of the API, 10% to the new version of the API. My assumption is that we will see other service mesh interface spec conform possibilities here. So for example, to route requests based on contextual information like HTTP headers or user agent, stuff like that, right? So Envoy, and that's a good thing of that story, Envoy is able to do it. I think the Azure Container Apps team just has to bring it up on the roadmap and make it available to us. And if we have multiple containers running in a container app environment, then you can either call them using Dapper service invocation if you are using Dapper. If you're not using Dapper, then you can just invoke that HTTP endpoint or gRPC endpoint on the other container by using the DNS name, right? And for the Kubernetes folks here in the audience, you can think of a full qualified service name in Kubernetes. So in Kubernetes, we have we can create a service with the name my service, and the Azure Container App environment equivalent of Kubernetes is the so-called namespace. And then we just have the service type and the DNS suffix that we are able to address it. So that's exactly the same concept, right? So Envoy gives us the possibility to either route requests into Azure Container Apps or it allows us to call into containers in a particular environment. Yeah, there's Dapper built in. So what the Azure Container Apps team also did with Dapper is it took the Dapper components specification and brought that into Azure ARM APIs. So you don't have to, let's say, run the Dapper sidecar containers Microsoft injects them automatically. So only if you mark a certain container, hey, please use Dapper, then they will inject Dapper for you, and you don't have to care about it. And again, it's 100% optional. You don't have to use it if you don't want to use it. It makes things easy that they just, the entire Dapper placement and Dapper D stuff is already built into the service. So if you want to use it, just specify it and they take care about heavy lifting. That's quite nice. KEDA, yeah, as I said, it's about contextual scaling. And the good thing is, if we just, let me quickly kill that one and take, let's take a browser over there. KEDA.sh. KEDA has so-called scalars. And right now, if I remember correctly, 36 scalars or so are currently available. And it's not just Azure, right? KEDA is a CNCF, so Cloud Native Computing Foundation project. That means that everyone can contribute scalars to KEDA, and the CNCF keeps watching that or ensures that KEDA stays cloud agnostic, right? So just because you're using Azure Container Apps, it does not limit you to have everything in Azure. So for example, you can scale your containers in Azure Container Apps based on AWS CloudWatch or GCP PubSub, whatever, right? You just pick one of those scalars over here, and then you can just configure it using Bicep, for example, to have your Azure Container App react or scale based on metrics in one of those systems. So that's what KEDA brings to the table. And again, the good thing is the entire, the entire runtime, all components that KEDA requires to work typically in a Kubernetes cluster are already deployed into Azure Container Apps. So you don't have to install or maintain or upgrade KEDA on your own. All right. Let's get started. Enough slides. I have an Azure subscription over here. Let me quickly refresh. And there's a hard caching. Let me empty cache, hard refresh. And let's bump the font size. Funny thing, that should not be there. I think it's hard cached. Whatever. So I have a bunch of samples over here, and I want to start with a plain old hello world. So the repo is already open source, but I will share the link after the talk, so you can download the samples, play around with them, taking them as a starting point. So the first example does not address, let's say, infrastructure as code or something. It's just, what do you need as a developer or as a DevOps person to get something up and running, right? So there is an Azure CLI extension that you have to install in order to use Azure CLI commands to interact with Azure Container Apps. That's called Azure Container App. Then we have two namespaces that we must register or ensure that they are registered in your subscription. We need two namespaces because during preview phase, the team refactored the ARM namespaces from Microsoft.web towards Microsoft.app. And I'm not 100% sure if that migration process is finished or rolled out through all Azure subscription already. So to be on the safe side, register those two providers. And then there's then it's fairly simple, like day-to-day Azure business, right? You spin up. So we need a resource group, and we have to obviously deployed in some kind of region. Azure Container Apps is right now available in North Europe, North Canada, and I think East US. I think those are the 3 regions that where it is rolled out right now, but the team is working on more and more regions. And yeah, to spin up a new Azure Container App environment, so the one is called Hello Akka, we always need a log analytics workspace, because what Microsoft automatically does for all the containers you run in Azure Container Apps, they forward standard out and standard error from all the containers into log analytics workspace, so that we are able to dive through the logs and see what's happening when a container gets started in Azure Container or Azure Container Apps, or why did a certain container stop working, so we can dive into and get the logs from standard out or standard error, which also implies that we as the .NET developers leverage the iLogger and instruct the iLogger to log to the console again, because otherwise, you have to go to a third-party system, which makes no sense. Okay, so we create the resource group, then we create a log analytics workspace. I also grabbed the workspace ID and the key to access log analytics workspace in the new way. And then we create the environment, right? It's like the logical container for our container apps, just specifying the name, the resource group, and point it to the log analytics workspace I've just created in the line above. And last but not least, we say, hey, Azure Container, please create a container app with the name Hello Akka in resource group name in that certain environment. I point it to a container image. In this case, it comes from public Docker Hub. And I'll say, okay, I want that container exposes port 80. Maybe if you have used Azure Web Apps for Container, they do to kind of port scanning, right? If you don't specify a port, they iterate over all ports starting at 80 up until something, the timeout kills the process. Here we have to explicitly tell Azure Container Apps, okay, this container image, where can I send HTTP gRPC calls to? What's the port that you want to, or that is exposed by that image? And then I instruct, hey, Envoy proxy. So in the simplification, it's not Envoy, it's just the ingress. Yep, I please want to route requests from the internet into that container on port 80. Last but not least, I use a simple query to ask for the full qualified domain name that will be assigned to that Azure Container App once the deployment has finished, and then I just print out the FQDN. So let's give it a try. Oops, yeah, let's go to the right directory, obviously, and say deploy. Okay, so it's ensuring that the extension is installed. Then it's taking care about the provider registrations, and then we are already spinning up the resource group and the log analytics workspace. A word about container app environments in the meantime. Right now, there is a limitation that you are only allowed to deploy 2 Azure Container App environments per Azure subscription. That's a preview limitation. The team is already working on increasing that limit. But yeah, for now, that's the limitation that we see. But we can obviously, deploy multiple containers into a single Azure Container App environment without any restrictions or limitations on that level. So it's just good to remember that it's right now limited to 2 container app environments. Okay, so it's deploying my container, and there we go. We got fqdn. Let's take this one, go over there, bring up a new terminal. First hit takes some time. Oh, pretty fast. There we go. So we see the Gopher being displayed here. And let's revisit that in Azure. So we got the resource group. In the resource group, we got the container app environment. So the representation in Portal is under construction, let's say it that way. So from time to time, you may see, some blades appearing, disappearing, but Azure Container App Environment is still very fundamental. There's not a lot to see over here. So we can just go to the apps and see, okay, there's one app deployed to that environment. And there we get a bunch of more stuff. A lot of the things that we see right now, they have been released a week or two ago. And it also gives you an understanding, okay, what is possible, right? So we can do continuous deployment, obviously. So we can point to either to GitHub, or we can point to a container registry and say, if a new image or if a new tag gets pushed to that certain particular container image, then automatically take it and push it. We can use managed identities, so either system-assigned or user-assigned identities that Azure Container Apps will use and attach to or to run that particular container, which makes integration with other Azure services easier because we can do it passwordless, right? We can just, configure role-based access control on the upstream services, and then use SDKs or HTTP endpoints to call into them. Ingress, we've already configured that, and we should see, okay, HTTP ingress is enabled. So if it is enabled, then we can limit access to either a VNet if VNet integration is configured, which is not for this app, to that environment, or to the internet. If we disable it, then the public endpoint will be removed again. Speaking about the public endpoint, so I got that nice subdomain underneath or underneath containerapps.io. Custom domains are not yet supported, but they are on the roadmap. So what we typically use is we have Azure App Gateway sitting in front of Azure Container Apps and other Azure services to route requests through Web Application Firewall and point them then to the containers that we want to. Revision management. So right now we are running in the single revision mode, and we have just one image deployed, but we can change that. Let's go to the containers side over here. And let's say edit and redeploy. And let's, the container is up there. Let's add a new one. Do I want to add a new one? No, can I change? Oh, I can't change the existing one. That's weird. Let me quickly check. That's still. Let's try that again. So that's the portal experience. Can't I edit that one? I can edit that one. Okay, let's go to Docker Hub quickly. Hub.docker.com. I think it's that. Is it? No, that's not. No, not Hero. Gopher, sorry. Okay, let's go with that direction. And there's Gopher. So that's the image that I'm using. And there are there's space. So let's take the space. So tag here. That looks good. Scale 1 instance should, I think, 1 instance should be enough to handle my requests. So come on. Okay, so deploy the revision. Oh no, but still 1, because I have to set to multiple, and then save. And then we have to bring in the older revisions. And now, yeah, what's up? Okay. Now we can say we want the latest should be 10. And the previous revision should be 90, get 90%. So right now, 1 out of 10 requests should see the space gopher, and the other one should remain seeing the hero gopher. Let's try that. Refresh, 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 refresh. There we go. So we see it sometimes switching or applying to traffic split logic. So yeah, portal experience is still getting, or is getting better and better, but we can quickly, bring in new revisions and change the amount of requests that will be routed towards that particular container. So that's from the portal experience. So we saw how to, let's say, script the deployment using Azure CLI, right? We saw how to create a new revision in the portal. And let me quickly destroy this one again, because otherwise I ran out of container environments. All right, so sorry for jumping back to a light screen again. It should, at least. There we go. So getting started is fairly easy, right? We can all create the environment in portal. That's also possible, but typically what you want to do is adopt some kind of infrastructure as code, or to professionally, let's say, deploy it in order to being able to redeploy it if something bad happens. So the entire story is, how can we provision Azure Container Apps as a service in order to have it in a robust way. And so what the team did, they took all the capabilities like CADA, like Dapper, like traffic splitting, and brought that together into 2 Azure Resource Manager entities. That means they had, so Bicep was top of their mind when they designed that approach. And Bicep is, up until today, from my point of view, the best way how to provision Azure Container Apps. Pulumi also has a story on how to provision Azure Container Apps, and I think they are on that. They support it right now for a couple of months, but Terraform does not have a story yet. They're tracking progress in that issue that's linked over here, but still we don't have Azure Container Apps there yet. Azure CLI, we already saw it, just for reference. That's again mentioned over here. But the interesting thing is, okay, so we can take Bicep to provision this service, right? To provision Azure Container App environments and the container apps, but we can also use it to provision the actual workload, right? So to provision the container. Unfortunately, or let's say it that way, although we can use managed identities or service principal, or so manage user assigned identities or system assigned identities for our containers, we cannot use managed service identities to talk to a protected container registry. So if the sample I was showing earlier, that one came from public Docker Hub, so there's no authentication involved at all. If we create an Azure Container Registry, right, we can say ACR create. And if we take a look at the documentation, we can say, I think, is it? No, it's only possible if we update an existing one. We can enable anonymous pull so that we can, that you can, for example, if you want to have everything governed in your Azure subscription, but you have your public container images that you want to share or to be discovered by someone, then you can use that one. If you have, so for me, typically, in my day-to-day job, all the images must be secured, they must be protected, and we must ensure that only authenticated and authorized services and people are able to pull them. So what we can do is, upon creating a new ACR instance, we can say, to quickly enable the admin account, which gives us God mode to that registry. So there's an admin user that's called with the same name as your container registry instance. And then you have 2 passwords that you can rotate if in the case that you leaked one of the passwords or that you want to rotate your passwords from time to time. But there is a better approach. So given the fact, right, that we can't use managed service identity to pull those protected images, we can use so-called scope maps and tokens in Azure Container Registry. Let me quickly, instead of waiting for ACR to spin up a new instance, I have plenty of instances, I guess, over here. Let's look for container registries. Yeah, let's take this one. And that's a premium school. So that's the requirement. Obviously, if you have an ACR on a premium school, that's 72 euros a month, if I remember correctly, something around that. You're able to create scope maps. Scope maps, you can think of custom authorization patterns, right? So that you can say, for example, pull, and then we can say, so this has an API. An API container image is stored in that container registry. But let's say we want to store multiple container images in a repository pattern called net Oxford /. So with ACR, we are able to use or to create like a folder, but only one level, right? We can't do nested repository names. Okay, it's not there. So we can, yeah. Just in case, yeah, it does not matter if it is a folder or if there are 10 images called net Oxford API frontend, whatever. And then we can say, okay, the user are able to metadata read and content read, so they can check if that repository exists, if the Docker image exists, and if it exists, they can pull it, so they can download it. So we can create a fine granular scope map, and then we can create tokens. Let's say it, and we link that one to pull. Then we create that one. And then we have to scroll over there because I zoomed a bit. Ah, no, we have to click it. And we have to set, let's set the expiration date to 1st of June, 2023. No, it's a little bit too long. Next month. And as you can see right now with that password, we have a combination, or we are able to log in on any machine, or on any machine we can invoke, hey, Docker login with the user net Oxford with that password. And at the end, there is, I mean, the tooltip shows it. There's obviously the endpoint from the Azure Container Registry shown. So we can use that approach to authenticate not just Azure Container Apps. We can use that approach to authenticate anyone, no matter if it is an Azure user or not, or if he has any clue about Azure. And yeah, so we can leverage private registries also with Azure Container Apps. So that's, I would say, up until we get the managed identity support also to pull our container images. Just a quick run through Azure Container Registry. So I said bicep. Bicep is a story, right? Let's do the second sample, and then I think we can jump into a quick break. So the second sample is pretty much the same from the application perspective. It's an Azure Container App environment. It's a log analytics workspace. It's bringing up a simple container. And the Docker file is, again, from Docker Hub. It's Paint, but we're using bicep. So let's log analytics workspace. We don't care about that one, right? It's just log analytics workspace. Let's scroll up. So this is the new scheme, and I think 90% or maybe all of the subscriptions are already migrated. So we specify the environment by just providing the name, the location, linking it again to that particular log analytics workspace. And then we have Azure Container App environment representation, name, location again. We point it to the app environment. We specify if the ingress should be external or not, and which port. And then we specify a template. So how or what makes our app an app? At least we have to provide one container. And that container is built from a certain container image. We must give it a name. We give it a name in order to stream logs in scenarios where for example, if you're using Docker, right? They start a smaller container, a small Dapper container next to your actual container. And in order to stream logs from your container, instead of streaming the logs from your container and the Dapper container, you can provide the name of that container. And that's why you have to provide a name again over here for your main application container. We can bring in things like environment variables, secrets, and stuff like that. And then if you, for example, if you worked with Azure App Services, you may remember, or you may know about the always on switch. That's the always on switch. So that Azure Container App environment does not destroy that one instance. If we go with that, it may destroy that instance if nothing happens. But if a request hits the ingress, the container is immediately fired up again. Immediately firing up a container in Kubernetes means if we deploy with this configuration, the image will be pulled on the machine. So the image is locally, and spinning up a container locally, I mean, that's Docker run like that, right? And that's the same in Kubernetes because the image is already there. So if you want your image to be always on, you can go with a min replica of 1. And that's it. So for the Kubernetes people, we don't have to care about config maps. We don't have to care about secrets. We don't have to care. We don't have to specify objects of type secrets. That's that way. We don't have to bring in a namespace. We don't have to bring in services and stuff like that. That's all compiled down into that. Let's say reaching up to line 40, starting. Let's say 24 lines of code. That's everything we need. So I have created a module over here to, draw the picture how to reuse that bicep file over here. So the actual usage for paint. So there's, if you remember, there's a paint container image that has a port 80. I specify the container app environment, and I specify my paint app, just linking together everything, demonstrating how to set an environment variables over here, and say, I want external requests being routed to that container, and the container port. Let's put that over here, makes more sense. So I want a request from the outside being routed to that port of the container. Let's give it a try. So cd02, and let's do an AC bicep upgrade, because that was yelling at me before the talk already that I should upgrade my bicep. All right. So there's again a deploy script. Let's quickly share that one. The deploy script is just, creating the resource group and firing up the bicep deployment, just to save some keystrokes. Again, we're doing it in off Europe. So let's say /deploy, creating a resource group and starting the bicep deployment. And the cool thing about bicep compared to Terraform is that we don't have to look at the terminal. We can go to the resource groups and hope that Azure caching is not that tough. There we go. And we can go to deployments and see once the dependencies are deployed. Come on. We should see it expanding. Okay, right now it needs to deploy the container app environment. And you will find yourself troubleshooting in the deployment window, in the deployment blade over here. Because typically if something fails, with authorization or authentication against the ACR, then the deployment will fail. You will get the exception also in your terminal, obviously. But from time to time, there may be some further details being included in the error message referred or shown here in Azure Portal, or you can query it using Azure CLI. But that's a good starting point to troubleshoot. Oh, come on, waiting for the cloud. I'm not good in waiting. Okay, so the environment is there and the app is not there yet. It tells running. Really not good tonight. Okay, it's right now deploying paint. And once paint got a green check mark, we should see the green check mark bobbling up to main. Succeeded. And the entire deployment is also succeeded. Okay. So block sample. Then there is an app. There is paint. And paint has an ingress routing, so we can just click it. and we got page. I'm not good in painting. Hello. Great. So similar story, right? Different container, but right now we're leveraging Bicep to have an infrastructure as code story. And the good thing is that Azure Container Apps team built the service with infrastructure as code in mind. So that's from the very first bits we got. So the very first preview, we had access to Bicep integration, or yeah, we were able to deploy it with Bicep. And perhaps a small hint, Azure Container Apps, ARM entities. That's always, so I use the specification to see what's coming, because from time to time they publish ARM specifications over here. For example, oh man, there was a quickly check. There was another link. There was another link. I think it's in the somewhere is the link to the ARM documentation. But I can look at that up during the break, because from time to time you see new interesting properties popping up there, and that may be a sneak peek for things that are being released in the near future. So that's a good thing. I stumbled upon health props that way, just by reading through the specs that were auto-generated, and quickly try to find that. Azure ARM IRF. Oh, that's good. And let's, oh my God. Container instances, no, where is it? Container apps. Is it under preview? Maybe. Let me quickly check container app. Searching for all the docs is not a good thing. I think that's it. No, that's the same I was. Okay, I will double check it in during break, because there was a reference. And yeah. Alrighty. With that, Matt, so next, and I hope it works, because it did not work an hour ago, is a little bit more, a little bit interesting, because we have an app that consists of multiple containers, and the scenario is fairly easy. It's a Cosmos DB behind the scenes, and that's why I hit deploy quickly, because then I can guide you through the sample while Cosmos DB starts provisioning the instance. So there's a Cosmos DB acting as data storage, and that there is an order API it's written in Go, but it actually doesn't matter. It has two HTTP endpoints, one that is that we can use to persist a new order, and the other one to get an order by its identifier. So the API, as I said, it's just those two endpoints, one with post, one with get. So the good thing about Go is easy to read. Because all I do is just, using Dapper's Dapper components to get rid of, technical details. For example, I don't want to implement storing something in the database, or in Cosmos DB in that case. I just say, hey, Dapper, please store something. Something is in order, and I just provide an identifier and the document that I want to store, or binary representation of the object, right? And for reading an order, I just say, hey, Dapper, get state. And so there are Dapper SDKs for .NET, Python, Go, whatever. And we can also interact with Dapper using HTTP or gRPC if we don't want to, tie our application code or don't couple it that tightly to Dapper itself. So, but in that case, I decided, okay, let's use all the latest and greatest that Dapper offers. So I don't have to care about, using the Cosmos DB SDK to store data, to read data. So that's the one service. The other service is the most fancy inventory service ever. It has a method that we can use to ask if there are items in stock, if my VS Code decides to scroll at some point. With router error RP over there. There are items I can, there's a hello endpoint. Yeah, it's just rendering hello. And there is an endpoint that can ask, hey, is the item with ID X in stock? And the handler just returns, it is in stock. Yeah, so fancy business logic, the hello just renders hello. So those are the two backend services, right? In front of that, there sits a facade. The facade is again a fairly simple API with hello orders that I can post a new order to. So my public API surface, let's call it that way. And for every endpoint, there is again a handler. Let's go to Dapperizer. And yeah, get orders, good example. It takes the value that is provided to the facade, like the identifier, and it's just, issuing a new HTTP request to the Dapper sidecar container. So that's running on localhost, but on a different port, right? So I can call from my API to the sibling container and say, hey, please invoke order with the identifier. And all I said is an HTTP header and tell Dapper, hey Dapper, look for another service in my in my environment with the identifier order service name, which is order API. So Dapper does the service invocation under the covers for me, and they do a retry pattern where they try to reach to the backend service 3 times before they, report an error to the caller. So that's just, those 3 containers using Dapper as the glue between each other to hide a little bit of technical plumbing or necessary implementation that I have to do in order to connect those containers to each other. So the bicep file, so the environment is the same. The Azure Container App module is also pretty much the same. Let me quickly minimize this one. So again, we have, we have secrets, because in this particular case, I want to pull the container images from Azure Container Registry. So those were provided in the deploy script, right? There are environment variables on my machine right now for demonstration purpose, because otherwise I had to type them in at the point when I say, hey, deploy. So I store them as secrets in Azure Container Apps. And yes, this is a limitation right now. We cannot use Key Vault to link secrets from Key Vault at that point over here. Ingress, we saw that a couple of times right now. We have containers. Again, I specify my app containers, one for order, one for facade, one for inventory. We'll see that in a minute. I link environment variables. I say, I don't need any kind of scaling mechanism, just always run one instance. And I add another property over here. That's a Dapper property where I say, this one I want to use, or for this one, I want to use Dapper. Then I have to tell Dapper, hey, if the sidecar comes up, then on the same host, on the same virtual host, on the port, on the port of the actual container app, there my application runs, and I have to bring in the Dapper components that I want to use. So Dapper components, if you're not familiar with Dapper components, dapper.io, we got, let me quickly go to the docs. Getting started, now developing applications, building blocks. So Dapper can do several things for us. So we have, in that example, we have service-to-service invocation, facade calls orders, facade calls inventory, and we have state management. So order, service, store orders, or get orders from the state management system. And yeah, just for completeness, if we go to backend stores, these are right now supported. And if you go, for example, you want to do pops up, then it's not linked over here. Then we go to reference, components back, pops up. And then you see those are the systems that you can use for pops up with Dapper, right? And you don't have to learn the Apache Kafka SDK or the RabbitMQ SDK. It's always, hey, Dapper, publish a message. Hey, Dapper, receive or react on a message. So that's taking away the technical plumbing. All right, so it's fairly the same, right? Just a Dapper component and some small additions because of the private container registry. And it all comes together in a main.bicep. Let me scroll to a bunch of variables to make it reusable. So we have several container images all pointing to the protected container registry. Every container is exposing its service on port 8080. And the facade is the only one that should use, the ingress or should instruct the ingress to being exposed to the internet. All other servers should not be exposed. And I think that could be the problem why the demo did not work before the talk. Okay, just keep that in mind. So then the container registry, username, password, stuff like that. And these are the names that we associate with each, let's say, component in the Dapper context. So the order API, so the facade is able to call, or Dapper is able to call the order API by referencing it as order-API, no matter how the container is called at runtime, no matter which DNS name is associated. In Dapper, we just need those 3 magic strings, right? So we have the environment, we have the database, and then we have the order service. We link together everything that's the same as we saw before, but then there's a Dapper components. The order service is the only one that has to persist state. So we say, hey, I want to use Dapper components. In that case, I want to use state persistence. I provide it with the endpoint of the Cosmos DB account. So that's the primary connection string, if I remember correctly. And I have to specify, okay, put all data in the collection orders and in the database orders DB, and in there create a collection. Then I specify the password as a secret in the Azure Container App. So we get the password as a secure string. Then we hand it over to every container app, because every container app in that environment must know how to authenticate with Azure Container Registry. And then there's the inventory service. Inventory service has no Dapper components, so it's just plain Azure Container App as we had it before. The only difference is that this one also has to, authenticate against Azure Container Registry. And the facade service is pulling, again, the image from ACR, but we want to use service invocation. And typically the facade API, you wouldn't, in Kubernetes, you would use the full qualified service name. But because we can use Dapper, we just have to provide those magic strings. So the order service is called order API in the Dapper Cosmos. And the inventory service, no matter how it's actually called, we refer to it as inventory-API. And last but not least, I just grabbed all the FQDNs and provide them as output. Okay, in the meantime, Cosmos DB has provisioned. Let's give it a try. So resource groups, refresh. There's the multi-container app. And we see there, there's also application insights being deployed. But there's the Cosmos DB account. Let's open that in a new tab because we want to check it later. And then there is the facade API. And there is the public endpoint. Let's copy that. And let's bring up Postman. And let me quickly increase the font size. Oh God, where is it? Oh, there. Yeah, the font size is increased, but not in the regular window, right? So that's it. Let me edit. And let me set the public endpoint. Was it with the slash or without the slash? Can't remember. Hello. Yeah. Okay. First hit can take some time. Oh, come on. At least hello should work. I had one idea while explaining the sample. I recognized that I have disabled ingress for all containers. But over the past weeks, I guess there was a new setting in Azure Container App that we must have to whitelist ingress also for the backend services. But then again, limited on the container app environment. Let me check that quickly. Inventory API, ingress. It is enabled. Okay, let's check on the orders API. Ingress. Enabled. Okay, looks good.
Do you need it enabled on the facade as well?
Yeah, but the facade was enabled, I guess. That was enabled with public also. Enabled, yeah, anyway. Did I grab the correct? I think so. Let me check again. Initial value, current value. So facade API include something with mesh mushroom.
When it was port 8080 on the facade.
Yeah, maybe that's the case. Port 8080, that's a good thing. Yeah. Port 8080. Save. Cancel. Send it again. Let me try this one. It's a link to port 43. It's not okay. Let's troubleshoot because we saw log analytics workspace a couple of times, and previously before the session I got the message that the Dapper sidecar was not able to start because of reasons. So we always get that log analytics workspace, and then we can just go to the logs and we see Right now in preview, we see the usage and we see the container logs. Let's minimize this and let's go to the order API. There's an error that looks like Dapper client is context stack client exceeded. Yeah, that's sad. That's the same error I got right before the session. I'm not sure why. But let's quickly say where container app name equals facade API. Run that one. Dapper HTTP port not set. Oh, interesting.
You get a little apology too. That's nice.
Sorry?
You get a little apology too. That's nice.
I think that was a message that I wrote. It's not a Microsoft message. Interesting. Where's the size? That's interesting. Depperizer. Let's quickly double check that one. And it's over there. And the Dapper root I have. Yeah. Okay. Order service, the Dapper HTTP port. Why is that not set? That's bicep. There's over there. And what happens if the facade calls over there? Then it goes to this one. Dapper is enabled true. Just trying one more time with setting Dapper to not null. Setting Dapper, just double checking Dapper components to an empty array.
Was it asking for it as an environment variable?
Yeah, but typically when Dapper injects that environment variable.
Okay.
Because that's the only thing that is because state service-to-service invocation is actually not a component, it's built-in capability, but it looks like it is not able to recognize, or it's not recognizing that it should start a Dapper container side by side. So maybe that's due to a change in the specification. I mean, otherwise, I can try to. I can provide a Dapper HTTP port. Typically, it is port 9001. But let's give the deployment one chance to fix that. That's so sad. Because the inventory does the inventory need Dapper component? Obviously, that should report the same error. But it does not need any kind of Dapper. It does not do any kind of invocation. That's why it doesn't matter for the invocation, for the inventory service. It just matters for the facade service. Come on. What's about the deployment? Deployment. Refresh. Last modified. Oh man, that's long ago. It's taking its time. Also, obviously. Cosmos DB should be quickly done. Container environment also. Do we see Dapper port on the other API? Containers. No, it's just no. We don't see that. Why don't we see that? It's being created. Okay, it's right now middle in deployment. Oh, it's done. So obviously the hostname should not change. Let's verify something with mushroom. Yeah, that looks good. Let's give it a try. Looks like same behavior. Oh, and this one. And 39 something. Let's quickly order by generated disk. It's log s. It's the same error. That's weird. But you can trust me, I will troubleshoot that this night and push it to the repo. I'm not sure why it fails. Why it fails today. Somehow it's not starting up the Dapper host for that one, for the order API. Let's try that one. There I get the context, the deadline, something. That's weird. Yeah, I have to double check it again with the specifications. Sorry for that one. But I have other demos. Next one is one that I stumbled upon because I got a customer that wants to do a front-facing gRPC. Quickly check groups list. Let me delete this one in a group. This one, yes. Let's kill that one too. Okay, so gRPC, the good story is we can expose gRPC within Azure Container Apps without, without any further ado. We just need to ensure that we set the transport to HTTP2. So that's another property that we have not set up until now, because by default it has the value of auto, but changing it after you've deployed it with auto to HTTP2 is not recognized by Azure Container Apps, which is a preview issue, let's say it that way. So the workaround is either uploading a new revision, so deploying a new revision, or setting an environment variable, which results in a new revision being deployed for that container in the container app environment. But technically, so I have a service that's .NET new with the gRPC template. So there's a proto, just a greeter. that takes, the request and creates a response and sends it via gRPC to the caller. So there's the implementation over here, and it just returns hello concatenated with the name that is provided as part of the request. And then I have a client, which is again .NET new with the gRPC client template. I shared the proto. So then the client just invokes say hello async and provides .NET Oxford, and the gRPC service just responds to it. And it's more about exposing gRPC, which was a kind of tricky in, for example, Azure App Services, but right now with Azure Container Apps, that's a no-brainer. We just have to ensure that transport is set to HTTP 2. So again, with that one, it's just 4, and then there is a deploy script. And I hope the deploy script is not asking for something. But I think it's just creating a resource group, and straight deploying that thing. Okay. Server, it takes the service. And I think I pushed the container image to Docker Hub. Yeah, so that's in Docker Hub because it's not important for the demo where the image comes from. It's more important that we can just expose gRPC. And let me bring up a new terminal instance over here and go to for gRPC, the client, and let's say .NET run. And this one will wait and will ask for the FQDN again so that we can link it together. Yeah. So we can go to Azure portal, go to source groups, gRPC, then we should see the container app is already there, the app, not yet. Pre-deploying all the samples would work at some point when we get rid of the limitation of having 2 environments. Would be great for demos. Okay, the environment is there. Then let's go and check again. The app. But we're getting there. Okay. Overview. There. Apps. Hard caching. Yep. There we go. And then we can take just the FQDN and paste it over there. Paste. And we get the greeting back. So we're using straight gRPC exposed directly from within Azure Container Apps. That was a quick and small sample, but yeah, there was an actual customer demand, and I thought that remembering the issues and discussions we had with Azure App Services exposing gRPC, I thought it's worth adding it to the collection of demos over here. Another one, I mean, obviously you can take any kind of HTTP-based application and run it. So Chart Museum, if you're working with Helm charts or stuff like that, that's just a simple demo on how to link together Azure storage account behind the scenes using, primary access key to talk that Chart Museum can use as a Azure storage account as a state backend, let's say it that way. So that's pretty much the same like spinning up a single container app environment. That's we saw that a couple of times. But I think not the last one, but another important aspect and a feature that we got, I think 3 or 4 weeks ago in Azure Container Apps is probes. So Kubernetes, in contrast to running just plain Docker containers, right? Kubernetes can do things like desired state configuration or ensuring that the containers are up and running no matter what happens, right? If you have a cluster with 2 VMs and one crashes, then Kubernetes can take the workloads and start them on the other one, always ensuring that exactly those number of containers are being executed that you specified. And to do so, Kubernetes has health probes on all layers. And obviously, our layer is the container. And this one is also true for Azure Container Apps. So again, we have a simple API that exposes some endpoints like readiness, liveness, and startup. And if you take a look at the documentation, you have to go to the Kubernetes documentation. The AK team is still trying to catch up with documentation. So startup is a probe that tells, okay, the container is right now or has finished the startup phase, like bootstrapping the application. So this one obviously has to respond with the HTTP 200. And only if that startup probe responds with a 200, then the other probes will be invoked by the underlying Kubernetes cluster. So the readiness probe is, you can think of it like, is my application able to serve functional requests, so actual requests that it should deal with once users hit the API or hit the application, right? Again, this one must respond with a 200 to 299 response code, and then there's liveness, which is interpreted like a heartbeat. Hey, container, are you still alive? Are you still able to operate? And again, this one is must respond with 200 to 299. We can now specify those on the container app configuration by saying probes. And the good thing is that the schema mimics the underlying Kubernetes schema. That means we get a lot of configuration opportunities. So for example, we can say, hey, liveness. So that's the one that tells, is the container still able to do some work? We can say, okay, delay that for 50 seconds because my app needs, let's say, 2 seconds to bootstrap, then 1 additional second to build up a cache or whatever. And so I assume that the container heartbeat should start 50 seconds after that. Then I want to, invoke the heartbeat every 30 seconds. And if it fails 3 times in a row, then that container will be restarted. That's a mechanism that Kubernetes does. So it sends a SIG term, so graceful shutdown, or it's a graceful termination of the process that you must, react on in your ASP.NET or C# or whatever code. And then you can gracefully shut down your application. Kubernetes will wait for a configurable amount of time, and then it will just restart the container. Obviously, we can say how long may the HTTP request take, and then we specify on which port and where the HTTP request should be invoked. And startup and readiness are fairly similar, but yeah, we have we can't specify period seconds over here. So we can specify timeout in seconds, failure threshold, and obviously the HTTP endpoint that we want to call in. HTTP is one opportunity. The other one is a TCP socket that we can just use to check if the container is able to, if it has booted and bootstrapped correctly, or if it is still able to get some work done. I bet that we will see process health probe 2. So Kubernetes, the underlying Kubernetes also supports invoking a command in a container. And if the exit code is 0, then it recognizes it as a success. And if the exit code is not equal to 0, then it counts it as a failure. But right now we have HTTP and we have TCP. The good thing is, because Azure Container Apps is using or is based on Kubernetes, and we have that ingress controller, right? So let's say we have replicas of at least 2. So one container comes up and starts up, and at some point the readiness probe will be executed and it responds with a 200. Then network requests will be routed to that container. And that's the first point in time when requests will be routed to the container. If, however, the second instance of the container does not respond to the readiness probe, let's say 2 times, why? No matter why, then Kubernetes won't route requests to that instance of that container because it's not ready. It's not able to serve requests. So this also makes your app more robust, because Kubernetes is not maliciously, sending requests to a container that's not able to deal with it. So that's one of the not best practices, one of the must-haves. If you, no matter what you deploy to Azure Container Apps or Kubernetes, always specify readiness, at least readiness and liveness probes, because those are fundamental mechanics or patterns that Kubernetes uses to get its job done. So right now, for a couple of weeks, or since a couple of weeks ago, we are able to specify those also in Azure Container Apps. And that's really, really beneficial, especially if you think about, having, I have a bunch of customers that decide, okay, I want to optimize for runtime performance of the API. In exchange, I deal with a longer boot up time because I cache something in memory, or I build up a huge cache that is faster to access than accessing the database on every incoming API request. So right now we can deal with those scenarios also in Azure Container Apps without any homegrown solution or so. So that's pretty cool. Did I delete the other ones? I think so, right? Yeah, I think I have one container app. Let me check. Yeah, I have one. So we can deploy that, but there's no, we won't see anything because those insights are not yet, exposed via Azure metrics. So we just get usage at that point in time to see how or what's the actual, or why do I have X amount of euros on my bill? And we have those container logs. But over time, we will obviously also see all those logs being, forwarded to Azure Monitor, and so we can deal with those and put alarms on them. Which brings me to another demo that is not yet part of that repository. So if we, for example, let's say, make their net API. Oh no, let's say .NET new web API test is always good, right? Okay, so let's open test in a new instance of Visual Studio Code. And let's hit Command-Shift-P and say add Docker file. So I have the Docker extension installed. So the official, let's quickly bring that up. Docker. Come on. Okay, so the official Docker extension from Microsoft that gives you the command add Docker files to workspace. And then I can say, hey, it's ASP.NET Core, I want Linux, and let's say port 5000. Okay. So I don't want Docker Compose for now. But what we get over here, we get a pretty good Docker file that we can use it to get something up and running in Docker. It's not using the root user anymore. It's using multi-stage images, yada, yada. If you actually review it, it's restoring like 3 times, building 2 times. There's room for improvement, but it's a different story for a different day, right? So throughout the presentation, I've tried to demonstrate how to deploy it with Azure CLI, how to deploy it with Bicep, how to do it in Portal. But a week ago or so, the team came up with a new version of the CLI extension. And the new command that's there is container app up name test source dot. And what this command does, it is trying to find, hey, do you have a container app environment? Yes, there's exposing gRPC. It's spinning up a container registry behind the scenes, and then it's leveraging ACR build. So I provide source dot. So it takes the source or everything that's not ignored in Docker ignore, uploads that to Azure Container Registry. Then that one builds a container images, stores it in that ACR instance. Come on. I was talking too fast. Okay, it builds the .NET API. Okay, it published the .NET API. It copies it to the final container image. Okay, so now it pushes the final container image to ACR. Again, that's the ACR instance. They just spun that up. That wasn't there before. Now it's creating the container app. And within less than 2 minutes, we should have everything up and running in a new container app. Come on. Come on. Done. So there is a weather forecast API, isn't it? There it is. So we can just ask for weather forecast. There we go. So that's how it's called the inner loop experience. By just taking everything that we've seen in the past, let's say 1.5 hours, just automating it, right? However, that may add a couple of services. Let's go to exposing gRPC. That was the resource group that it's using, and you see there's some kind of weird container registry that's that they created on the fly. It's a basic, so it's not that expensive. It's basic free. Free was free. I don't know if basic's free. Schools, whatever. So there's a repository. They create a repository in that. That's my test repository. That's my container image. At some point in time, I may get charged also for the build hours or the build minutes. So there was that quick task, what they call it, that took roughly a minute. I can't recall how many minutes that there are free per month, but there's an amount of free minutes that you can just use to build your container images. Unfortunately, or not unfortunately, typically you want to, link those commands to existing resources to reuse your hardened, your trusted Azure Container Registry instance. So there's AZ Container App up -- help, and you can obviously provide your own log analytics workspace. Instead of spinning up another one, you can control how ingress should behave. You can use, instead of the local folder, you can just point to a GitHub repository and say, hey, use that GitHub repository. And you can say over there, use that particular Azure Container Registry and username password. That may be the admin user, that may be a token and scope map, as I showed it quickly in Azure Portal. Right now, they just support Azure Container Registry, because I think most other, I don't know if other registries have that build concept with a local source context. So that was one of the new commands that we got, I think a week ago or so. And the other one is the possibility to AZ Container App stream the logs directly, but I can't remember it now. Logs show, and then I guess we have to provide just a name for the container app. Enter resource group. Okay. So that is name. Then we go to apps. Test. Okay. Test. And the resource group is RG. Copy this one. Hopefully this one logs. Yeah, this one logs, so we can just follow it. Oh, it's a new CLI. It's in preview. We have to be a little bit more expressive. Okay, so we can just bring up the widescreen again, and with some delay, because log analytics must persist the logs. Come on. Oh no, it's not logging that one. It's just logging the start. Can I invoke just yeah, that's true. No logs. Yeah, makes sense. Information, and I think it's running in production by default. So let's change it over there. Information. And let's up it again. That would be interesting if it is able to identify that it has already deployed test. Downloading source code from the context of the ACR. That's why it says downloading. It's caching some of the layers, wasn't it? It was caching. No. Okay, that may result in we're just releasing a new revision. There. Apps. Tagged. Nice. Nice. So we can stream it again. Come on. Then there's a portal, then over here, then let's invoke the correct one again. There we see something happening, yeah. So we are right now able to have a better, let's say, troubleshooting mechanism than always going to Azure Monitor, going to console logs, container console logs, and filter that for container name. Because we can use this command, obviously, with every container app already being deployed, and no matter if you use Bicep or if you use the new AZ Container App. So I thought those AZ Container App up commands were a good closing demo because it demonstrates how inner loop performance could look like. A little bit more, or to be honest, how it should look like. That's something I would want to have for every service out there that I can throw something on. Yeah, so we went through Azure Monitor already, so we can get everything from standard out and standard error. So that's one of the key things to remember when you're new to containers. Always write everything to standard out, standard error. If you're running in Kubernetes, typically there are systems that scrape those streams and take the logs and push them to a log aggregation system. In Azure Container Apps, they use also a scraping mechanism and just, forward the logs to Log Analytics workspace. But they enrich those logs. They enrich those logs with the container app name, the revision, and so on and so forth. So you can, work with the data and to filter it according to your needs. That said, there was just a demo slide that I quickly skipped. That said, it is a frictionless runtime or a service that we can use to run single and multi-container applications, although Thorsten's demo today for multi-containers did not work as expected. From my point of view, it may be enough for most of the workloads that I've seen in the last, let's say, 12 months being deployed to a regular Kubernetes. So I think for a lot of projects, Azure Container Apps may be a proper runtime environment. Obviously, we will see more and more integration with Azure services. So we got easy auth. So, protecting your application on HTTP layer 7 on OSI layer 7 with Azure AD, with Twitter, with GitHub authentication, as we can do it with Azure Functions, or as we can do it with Azure App Services, Azure Static Web Apps. We can do it right now with Azure Container Apps too. So what I've seen, what I've seen so far is the adoption is pretty heavy. So it may be another service that becomes as popular as Kubernetes service became a couple of years ago. And I personally, I think the most interesting question is what will happen to Azure container instances? So that's one of the most interesting questions that is on my mind. Maybe it's there, maybe it's just final. I don't know. But I don't see anything that Azure Container Instances can do that Azure Container Apps can't do. That said, it's still in preview. There's no SLA. There is already a price tag on the preview. So the pricing is, yeah, it's public and you can just, you have to do the math, obviously. One thing that is actually, that's currently in development is volume mounting. And there we get, in the first place, we will get support for Azure Files and blob storage, if I remember correctly. Custom domains are not yet there. And as at some point I've mentioned it, we can provide secrets using Bicep or Portal Experience or Azure CLI, but we can't link it to Azure Key Vault. If you want to use that, then you have to use Azure Key Vault SDK to pull the secret upon container start or container bootstrap. However, that's not so cloud agnostic, because then you tie your container to Azure Key Vault. But yeah, in the end, what I would highly recommend is watching the roadmap, and perhaps if there's something that you miss in Azure Container Apps, finding an issue is one thing. The Container Apps team decided to use a third tool for communication with the community. That's Discord. So there's a Discord server. I think that's called in the Discord world, for Azure Container Apps, where the team hangs out and a lot of folks from the community. So with that, yeah, you made it. You made it to the end of my slide deck of the talk. But if you have any questions, just ask.
I've been keeping an eye on the chat window. I don't think, unless I'm missing something, there's any questions directly in there. But I'm guessing if people do decide they've got a question, Thorsten, they can reach out to your Twitter address or email. I think you put them on your first slide.
Yeah, it's just put it in the chat. Let's bring up that one.
There we go.
Yeah, but basically it's https://twitter.com.
Cool. That comes with the catalog pose photograph as well.
Oh no, oops. I just accidentally deleted a couple of slides.
Excellent. I'll be more next time you
there we go. Yeah. So if there are questions, just shoot me a mail, or reach out on Twitter. I think this service is, especially with that AZ Container App up, that one is impressive. That one makes it so easy to get started, right? So spinning up ASP.NET is a no-brainer, right?
No, it looks really good. Thank you very much